Hare Krishna. Today we are going to run a simulation of solar eclipse, and we'll understand how an eclipse occurs. So for today's simulation, I have chosen to simulate the total solar eclipse that happened on December 14th, 2020, and it was visible in the southern hemisphere, specifically in Argentina. So for this location, I have for the simulation, I have selected the location of Rio Negro, and then we'll see how the eclipse occurs. So as we know, for the eclipse to occur, the sun has to be blocked by the moon, right? And the moon has to totally cover the sun. Now, in the previous video, we learned about moon is generally either north of the ecliptic or the south of the ecliptic. So here we see the moon, and this is the ecliptic, but the sun is always on the ecliptic, right? And so the moon only on two times every month, it crosses the ecliptic while during its ascending motion, and also crosses the ecliptic during the descending motion as well. But when that happens, right, it's not that every time it crosses the ecliptic that an eclipse occurs. But a couple of times a year, what happens is when the moon is crossing the ecliptic, it is crossing obviously at the nodes, either the ascending or the descending node. But it so happens that sun coincides, right, with the ascending or the descending node, and that's when you will see an eclipse occurring. So when that alignment happens, it doesn't happen always, but only happens a couple of times a year. So that's what we're going to simulate today. One more thing, as I mentioned in the previous simulation, is that the eclipses which are caused by Rahu, right, or the ascending node of the moon, they are only visible in the northern hemisphere, and the eclipses which happen at the descending node of the moon, or Ketu, they are visible in the southern hemisphere. So anytime if you see an eclipse, you will know whether it's caused by the ascending node or a descending node, depending upon the place from which it's visible. If the place is in the northern hemisphere, it's Rahu. If the place is in the southern hemisphere, it's Ketu. Okay, so let me go ahead and run the simulation. I'm going to back up a little bit, and what you see over here, I'm going to lock on the moon, right? So I'm backing up a little bit, but as you hear, what you see is moon is just below the horizon, but here the location is southern hemisphere, right? And so the definition of below kind of changes. You have to flip the convention, because the signs are flipped. Let me pause over here just to make sure it's clear. So here it appears when this moon is going to cause an eclipse, it appears below the ecliptic, and it's going to ascend and cross the sun during its ascending motion. It would appear like that, but actually it's not the ascending motion, it's the descending motion. And how I'll just prove you is that when you look at things on the southern hemisphere, the zodiac signs are flipped, and I'll tell you what it means. So like over here, you see, this is Sagittarius. The Sagittarius is upside down, right? The signs are, when they are upright when you see from the northern hemisphere. When you look from the southern hemisphere, you see here the Capricorn is also upside down, right? So when the moon is, it appears below the ecliptic, but it's not below the ecliptic. Actually, it is above the ecliptic, right? Just remember that these signs are flipped, right? So if you look at Sagittarius, it's upside down. That means the moon right now is above the ecliptic, not below. Okay? So keeping that in mind, let's just run the simulation forward. I'm running the simulation at 100x, 1000x, right? It's evening, the sun is setting. Now one more thing, if you remember previous classes, I mentioned that in the southern hemisphere, the ecliptic appears inclined towards the north. You see, this is north, and that's south. See, the angle of inclination changes. Okay, let's keep going. Make sure you're locked onto the moon. Okay, and as we keep going, you see the moon is now approaching the sun, so it's above the ecliptic. Remember, the signs are flipped. It's getting closer to the ecliptic, and it's going to descend, right? Because it's above the ecliptic now. It's going to cross the ecliptic during its descending motion, and that means that's Ketu. The solar eclipse will only visible during the daytime, right? So now the sun's out, the moon is pretty close, it's new moon, right? Solar eclipse only happen on new moon, and it's crossing the sun. I'm gonna slow it down just to see. Now you can see the crescent shape where the moon is intersecting the sun. It's crossing the sun. I reduce the speed, so it's just slowly traversing through. Let me increase the speed a little bit. And then, so that's the descending node or Ketu. And right there is your totality. Right? You zoom across, you see, you could see the sun's completely covered, right? And that's your diamond ring right there. Now, and the moon's coming out on the other side, and it was above the ecliptic, and now it's going to go below the ecliptic. Remember, the signs are flipped, so the convention of the position is also flipped. So what appears above the ecliptic is actually below the ecliptic, and as the rays passes, you'll see that moon's below the ecliptic. So yeah, that was a simulation of how an eclipse occurs at either Rahu or Ketu. I hope you enjoyed it. Thank you very much. Hare Krishna.